Good day. Our topic for today is about the introduction of modeling and simulation. And I'll start with lesson 1. The things that we will be discussing today is I want you to be able to understand the key concepts of the system, the model, and the simulation. And at the same time, you should be able to demonstrate the simulation process, and then you will be able to determine as well the types of model, identify the areas of application, and what are the benefits in using the simulation. So these are the things that you will learn after or at the end of this lesson. So we will start with the definition, and of course we need to ask or why do we need a computer simulation, how it does, how it works, something like that. And you will also learn where and how to apply the simulation. Okay, so let's start with this one. When we're going to define a system according to the book of modeling and simulation, which is it refers actually to a part of potential reality where we are concerned with space, time, and effects in the causal relationships among parts of the system. Okay, so that is the definition from the book. Actually, the title of the book is Modeling and Simulation Using Python. I actually look at the book using the Java. They almost have the same definitions. I just get this one from the Python book. So here, when you define the system, it requires the setting up of boundaries. Just like when you create a system or you propose system, so you should have a very specific module or a particular features of the system. Just like this one, you try to model it in a real life, and by the later I will try to illustrate or show it to you how it can be related to the system. So when we say system, it says here makes the system closed world. And for now, it's hard for you to understand. You might be confused what does it mean. But along the way, you will be able to know how it is like. Okay, these are the examples. The system are actually including the energy flow when we are going to relate it to biological components in a pan. Another one is the physical motion of balls rebounding inside the closed space. Example, if you know how to play ping pong or lawn tennis or badminton, something like that. So that is what we call an example of physical motion of balls rebounding if you are inside a closed space. Okay. Another one is the customer service at a fast food restaurant. So we can also incorporate the simulation for this one. And usually this happens when you create a system like a simulation. During the training, you can also create a Q&A, and then there is a automatic or voice message. Somebody's calling up and then you will be answering it. So it's created through a system actually. Another one is the Federal Express. This is more of the logistic, the cargo. If you're familiar with Federal, if you have some packages coming from Lazada or Shopee, so this can be related to logistic as well, the Cargo Express. And next, so what is exactly a model? As you can see here in the picture, usually before it will be created into the actual, they need to create a picture and then try to emulate it using a prototype. As you can see here in the picture, it's made of plastic, but it is just a prototype, and it represents an object or a system or an idea in some form that it looks like according to Shannon. So instead of creating the actual, they have to start first with with the prototype, just like example, okay? Because they need to test whether the design is okay or whether they need to make some adjustment, whether it's a flexible. It actually depends because it requires a team to decide. They need to check with their clients as well as with their team, especially for the product design team. So they will be the one to decide whether it's okay. And at the same time, they have to coordinate with the technical team. So when we are talking about the technical team, it relates to, as you can see in the picture, so it requires velocity, and they need to measure how much it can carry of the particular thing, or when they try to turn the knob, whether it requires how many points or something like that, and then the screw, whether they need to have the many screws, something like, or they need to add more balancing. So it's like a collaboration with different team with different knowledge and skills. Okay, so here again, the continuation of what is a model. It is something we use in view of the real system, just like in a real life, in order for us to understand something about the systems. It's more of trying to, whatever in your mind, you try to illustrate it. You start from a drawing, and then from your drawing, you will make a prototype. And then once that you have this kind of prototype, when you are satisfied of your prototype, then that's the time that you will implement it. So the model of the system, it's more of an abstraction of that particular system, in short. Okay, so when models give us something comprehensible representation of the systems, or something to think about, or something to communicate about, so that is actually a model. Okay, so what are the types of models? It can be physical, and then these are the scale models, the prototype plans, just like I mentioned a while ago, where you can see with your eyes, physically, from the word physical, you can see that one. Another one is the mathematical model. So with this one, we can use the linear program, the simulation, and later I'll be giving you more examples. What is a mathematical model? Okay, and the process. So the process can be like in your software engineering, if you remember. So that is also included in the models. Okay, continuation. So here, the models can have many forms. Can be like mathematical equations, diagrams, or the physical mock-ups. The other one is digital mock-ups. Okay, one example of mathematical equation is just like this. Sorry, the image is pixelated. So this is actually a sample system. Example, you're going to develop a system where it can weigh a particular mathematical equation. As you notice here, there's minus 3x plus 3 equals 2x minus 7. And then it can be demonstrated through an object. So if you're going to create a system like this, because you will be the developer, it can be illustrated or demonstrated this way for the viewers, for them easy to understand on a particular equation. Okay, so this is just one of the examples. There are actually more examples which are related to the mathematical equation. Well, one example which is related to the calculus. So for you to be able to have a very good mathematical equation model, you need to have a good foundation in the calculus, statistic, and the other, or geometry. So more of related to the mathematics. If you really want to develop a system which is related to the mathematics, okay? Just like in, so can you give me an example of a something which is really hard to understand when it comes to a mathematics equation? Can you give me one example? Baldi Dumar, what's your last name? Baltimore, right? Can you give me one example in your mathematics subject? What you think really hard to understand, but no idea? Okay. So how about in your calculus subject? So there are actually in your algebra, it can be represented using a equation model as well. Anyway, let's just proceed. And so this is just one of the examples that you can look into when it comes to creating a system or a program. It's just like it depends. It can be a game based or it can be a more of the ordinary system, just like this. This one is an example of based on a game. So they're trying to weigh in the equation for a simple statement, whether is it easy to understand or not. Okay, so here the diagram model. So I use the Arduino. This is one of the example that you can also create as a model instead of I know some of you are using Arduino already, right? How many of you have any experience or a strong foundation when it comes to Arduino? Okay, that's good. And I know some of you are used into a physical setup, right? And you do the actual setup. So the thing here, when we say diagram model, as you notice here, there are wires, the green and the yellow. So here, the capacitor and etc. So this is an example of the system being created. And normally in some school, instead that they will do the actual implementation, connecting it right away, and to avoid problems, assuming some students might get broke the particular parts of pins or whatever. So to save something on that one, they will be using a simulation model through this one. Actually, it is existing right now. Are you familiar with the Tinkercad? Tinkercad. No idea. So none. Actually, in the Tinkercad, you can create a diagram model when it comes to Arduino, something like this. So in case, instead of connecting it right away, you will use the Tinkercad to connect all the wires and the other sensors and everything for you to test whether it works or not before you do the actual testing. Okay, and some school they usually use this kind of simulation instead of doing it in the real life. So it's like more of practicing first before they will do the actual connection. This is to avoid some problem. And sometimes it get short circuit, just like before when I experienced connecting my GSM modem and I accidentally use a what do you call this one, a battery, and connected into wire, so there was a short circuit. Although it's still working, but the GPS part it's no longer working. It actually exploded a little bit. So I had nothing to do because according to my supplier that it is related on the board, so it will take time for me to get back of my GSM model. Okay, that was based on my experience. So let's proceed now. The head question we did. Actually, this is just one of the examples. So there are many diagrams. I just give this example because you have the experience on how to use it. So I'm just giving you a tips that you can also do the simulation using the Arduino through the Tinkercad. So that's an example that you can use. Okay, so Going back here, physical mock-up model, just like this one. Have you seen, yeah, what you call it, like this, a physical mock-up model? If you can remember in your elementary days where your teacher asked you to create a small house, something like that, have you experienced it doing it during your elementary days? Yeah, using popsicles or whatever, well, or I forgot the term. Recycle from made of recycle thing. So just like this physical mock-up, and actually some product designers are still using it even up to now. Instead of building the real one, just like when they build a village, haven't you noticed it? Some realties, have you seen like that? Kumbaga, example, Camela, Vista, or some village selling houses, right? Or they're trying to showcase a particular project with related to some beautiful building, something like that. Instead of making some actual, they have to start with the physical mock-up model. So that is also one of the example that you can create. Just like you, example, assuming soon you will be working as a product designer. So you can actually do with this one, something like this. That is to present to your client. Okay, another one is what we call the digital mock-up model. Because before, actually, some companies are spending too much just to create some mock-up model. They spend millions, and nowadays we had the digital mock-up with the use of some software. Okay, just like this. As you can see, this is actually as a machine or part of the car. Instead of they build it right away, they have to make a mock-up model first. The setup, the looks, and everything, because they need to check the capacity and whether it works, and at the same time the color, everything actually is every detail of the particular product. And for this case, they have to coordinate with the mechanical engineer because mechanical engineer is related into this one. So it depends on the product. Even in the what they call this one, even creating some chairs or something machines, they have to connect or and collaborate with the industrial engineers because they are the one who is in charge for creating like that. And then with our laptop, the designs. So that is also part of the industrial engineer as well. Okay. So you have question with the digital mock-up model. Question? Any question? Okay, sure. Okay, so okay, then. Okay, let's go back to the model. So the choices of form actually depends on the purpose of the model. So it depends on which industry you are trying to model, and then the model is actually static. And when it comes to the presentation of the system, so let's talk about the simulation. So what do you see in the picture? So this is an example of flight simulation. Okay, even up to now, before the pilot will actually, oh, I don't know what's the right term, when they try to fly, they have to start with the simulation first. Even when they try to check what's wrong, what happened, what went wrong when the plane get an accident, something like that. So they will try to do a simulation, trying to the same what was the cost. So it can actually help them find the problem at the same time. So here, the simulation uses a model to emulate the dynamic characteristic of the system. So it's like more of an execution of the model, because in the previous examples, we only had a model, but there is no execution, meaning it's just visual. You can only see a model, but doesn't work. But with the application of simulation, that's the time that you will execute it and try to run it. Okay. Are you familiar with the SimCity? So that's also an example of the simulation. Are you okay? SimCity. So it's actually the method there is more of creating a simulation of creating a city, right? Is that correct? Okay. So of course, the quality of simulation only as good as the quality of the model. So it's almost like a real. Mm. This is actually good, especially for something very hard, or what to say, complex. And they need to do simulation first, just like if you want to fly to the moon. So before you go there and try to take a walk on the moon, so you need to do the simulation first. So that's the way to do some exercise. Okay? And then there's another example here. We're going to relate it into a system like this, a cannonball in a flight, if you can see in the picture. So the model here, we have the tennis ball. And then the simulation part is when you throw the ball across the lot. So here, if you're going to create a system like this, then you should be able to compute the height and the distance, and then the velocity. I'm not sure about the O. As far as I know, the letter V, that is the velocity, because this is related to physics. So here, they will try to compute the distance, just like before they're going to create this kind of this thing, they need to calculate whether if what if I'm going to throw the ball on this part, how long it can get there, what is the velocity and what is the angle, and what is the needed height or the distance, so that I can get this kind of velocity, or do I need to increase the velocity? So it's like more of testing. Okay, it's like experimenting on something, just like when in a real war, if you have you seen like this, if you're going to reflect this into a weapon of in war, can you guess what is it? Yes, the cannon. So something like that. Actually, the cannon maker, they do some simulation like that for them to know how are they going to create a ball, meaning they need to weigh in the ball so that they can also estimate how long it can reach, either from 2 kilometers, something like that. So that is also part of the simulation before they actually develop the system or the equipment. After creating the system, of course, next is to create the equipment. So that is in partnership with if we're going to relate it into the computer, it's like hardware and software. So same thing with this kind of thing. It's more of the equipment in the system as well as the software. Do you understand? Is it clear? Okay. So here, if we're going to define what is a computer simulation, it is actually ideal when a model can be expressed in terms of mathematics and logics. So how can the computer help or do? Of course, it requires a programmer for them to create it. And that particular programmer needs to have a good knowledge in mathematics as well, the knowledge, and because you will be doing the calculation. As you can see here in the picture, it's like a virtual reality. You are trying to make something which is unreachable. Example, you are here in Tandag and you want to see Palawan. All you need to do, you just do the virtual viewing through this one, virtual augmentation. It can be done through the use of what you call this the computer simulation. So here, the computer simulation can be easily store some information about attributes of the model and as you try to run on the simulation. So this is actually applicable for something which is really hard to reach. Example, if we're going to apply it in, if you want to see what is inside the ocean, so you can create a virtual reality and you can try to display the fishes, the shark, and whatever, baby shark, something like that. Okay, so it can be done through a computer simulation. Even the war, have you tried playing Counter Strike or whatever war games that have you tried? Yeah, that's right. So that is also an example of simulation. Even in driving, okay, when I start driving the actual driving, I actually started through a simulation. There are games using a car racing, so I started from there. Then when I'm familiar of how to ride, so I tried it in a real life riding on a car, and I was able to relate it on my actual experience and playing it through a computer simulation. So even the what you call on the driving center, they also have their own driving simulation before you actually try to ride on a real car. Okay, so here this is the process on what you call it, computer simulation. Of course, first you need to have the